Okay, now let's talk about this method of finding limits, which is a method of comparing your right hand and your left hand limits. Or we can say using your right hand and your left hand limits. Why do we do this? You say, why are we going to be using this method? Some limits are best calculated that way, okay? You first find the right and then the right hand limit, and then you find the left hand limit, and then you compare them. When we say right hand limit, we mean the limit as x approaches a value from the right. Okay? The limit as x approaches a value from the right. What is it? What is the principle that we use in this? Let me show you the principle. The principle is this. We say that if a limit of a function, as x approaches some value a, if the limit is equal to some number, if it's there, if it exists, this limit will exist if and only if, this is called a two-sided limit. We say the limit is f of x, the limit of f of x as x approaches a is equal to some number L, okay? In other words, it exists if and only if the left-hand limit, let's say limit of f of x as x approaches a from the left, okay, is equal to that L, and, oh my, let me zoom in, and the limit of f of x again as x approaches a from the right is also L, okay? So we are saying the limit, the two-sided limit will exist if and only if the one-sided limits are equal. Remember, one-sided limit is a limit that only exists if you're coming from one of the sides. Let's say the limit is only there if you're coming from the left, but if you're coming from the right, it doesn't exist. So that's called a one-sided limit, right? And that will not fail to be a two-sided. For it to be two-sided, to say this limit as x approaches a exists, that means as you approach a from the left, the limit should be the same as the limit as you approach a from the right. This is now your two-sided limits. Okay, this is now what we call a two-sided limit. So in other words, what are we saying? A two-sided limit exists if and only if both of your one-sided limit, this one from left, okay, if both of your one-sided limit are equal. Okay, this is from left and this is from right. So if both of your one-sided limits exist, then, and not only if they exist, but if they exist and if they are equal, then your two-sided limit will exist. Now, so what we are going to be doing in the method is we're going to be finding one side at a time. One side at a time. And then we will compare our answers and see if they are the same. If they are the same, then we know that the two-sided limit exists. Where do we use this method? We use it when we are finding the limit of a piecewise defined function or absolute value function. Let's go and see some questions. Let's start with piecewise, okay? So here we have our piecewise function. It's saying f of x is equal to 4x minus 2 when x is greater than 1. And it is equal to 2 minus 4x when x is less than or equal to 1. Now they say, find the limit as x approaches 1. Find the limit as x approaches 1 of f of x. And then we'll plot the graph. Let's find that limit. So maybe I'm going to say that we have our, let's write it down. It's you writing now your solution. I'm going to change the crayon. What color should I make it? Pinky, pinky, punky. I'll make it cream. Now we're going to say our f of x, right? I'm going to write my f of x is equal to, this is you writing, 4x minus 2 when x is greater than 1, and it is equal to 2 minus 4x when x is less than or equal to 1. So now I'm supposed to find the limit of f of x as x approaches 1. So the first thing I'm going to do is I will find the limit of f of x as x approaches 1 from the right. Then I'll find the limit of f of x as x approaches 1 from the left. So I find them one at a time. Okay? So what is the limit of f of x as x approaches 1 from the right? Now I want you to understand. Let's put our number lines so that we visualize. I like to visualize things. Here is 1. And x is on the right of 1 because we are coming from the right, right? and it is going towards 1. So x is some value on the right of 1, and we are going towards 1. What does it mean? If x is on the right of 1, is it greater than 1 or is it smaller than 1? That means it is greater than 1 because it's on the right of 1, right? So that means it's some number here that is bigger than 1, okay? No matter how close it is to 1, but it's still bigger than 1. So that means which one are we using? We are using this top function because that's all you do. You have to be using this to say if you're coming from the right, then is it greater or smaller? And then you choose which function to use. So I'm using 4x minus 2. So this limit is equal to, it is equal to the limit as x approaches 1 from the right of 4x minus 2. So my f of x, I've replaced it with 4x minus 2. I still write limit. I still write the limit. Now, what do you know? One thing I want you to know is when you are computing one-sided limit, we still use the limit laws, okay? The limit laws that we learned, we still use them. So now what do I do in this case? Whether I'm approaching 1 or 1 from the right, it doesn't change, okay? This is what? What type of a function is this? This is a nice polynomial function, so it's so easy, and we substitute, right? Exactly. So I'm going to just put 1 in there. So it's going to be 4 by 1 minus 2, right? Which is going to be 4 by 1 is 4 minus 2 is going to be 2. So that is my answer. That's the limit. Now, I'm going to find the limit as the limit of f of x. If you're not sure about how to get limits of rational of polynomial functions, just go and check the methods. We use substitution in the video on the 4 methods. So now what we're going to do, we are now approaching 1 from the left. Okay, what is this going to be? When we are coming from the left, we are now saying x is somewhere here and we are going towards 1. Is it smaller or greater than 1? In here, x is smaller than 1. So the crocodile, which is that inequality sign, faces the bigger one, and the bigger one is 1 for now. Because we are coming from the left, so we are smaller than 1. So that means which one are we going to use? We use this one, which says for smaller or equal to 1, you use 2 minus 4x. So it is equal to the limit. You still write in limit as x approaches 1 from the left of, is it 2 minus 4x now? I think it's 2 minus 4x, yeah? Yes, it's 2 minus 4x. So now we're just going to say, what is this going to be? Again, we have a polynomial function, so we just use the limit laws. What do we do when you have a polynomial function? You substitute. So it's going to be the limit. If you want to do it one by one, you'd say the limit as x approaches 1 from the left of 2 minus the limit as x approaches 1 from the left of 4x. Or you could say minus 4 times the limit as x approaches 1 from the left of x. Okay, you could still put the 4 here because it's just a constant, right? That is multiplying. So in this case, you'd get limit of a number. Limit as x approaches 1 from the left. We don't care where you're coming from. If you're getting limit of a number, your answer is just a number. Then minus, in here, you'd say limit as x approaches 1 from the right of this. You'd say it'll be 4 by 1. You feed into where x is. So it's going to be 2 minus 4 by 1 is just 4. 2 minus 4 is negative 2. You are done. Now, can you see? Are the answers the same? No, they are not the same. So they are not the same. So does the limit exist? No. So you can now say the limit, therefore it means the limit as x approaches 1 of f of x does not exist. Okay? So you could have said limit as x limit going to choose my crayon again. Would say the limit as x approaches 1 from the right is not equal of f of x, okay? Of f of x. F of x is not equal to the limit as x approaches 1 from the left of f of x. So the limit as you come from the right is not equal to that. So therefore, limit as x approaches 1 does not exist. How would I plot this? To plot your piecewise functions on part B, well, you're just going to put a graph. Let's say I put a graph. I'm going to put a sketch, something like this. Let me put it here. Something like that. Now, what are my important values? My important value is the value where these guys meet. And that is at x equal to 1. You see that x1 is the one working. So we have 1. Things are going to happen when x is 1 here. That's where your functions are going to do. Now, For the first function, this is whenever you see a power of x being 1, the highest power of x being 1, just being an x, that means it's a straight line, right? It's a straight line. And you remember that we say y is equal to mx plus c, and this c is the y-intercept, right? So what is our y-intercept? It is -2. So we know that it is a -2, but they said x should always stay greater than 1, right? So we know that the y-intercept, if we were to go to -2 here, the y-intercept would be the line x equal to 0. But they want x to stay greater than 1, so to be there, so we can't take it. So we are just going to pick a point and put into there. Okay, just pick a point. What you're going to do is just pick a point. Oh my. Let's do it like this. Just pick a point that is greater than 1. Let's just say 2, okay? And put it into this. So I would know when x is 2, what would this top function give me? It'll be 4. It would be, you can be writing, right, to say 4 x greater than 1, okay? You'd say f of x is equal to 4x minus 2, right? Say f of 2 is equal to, you're letting x be equal to 2. So you can say let x be equal to 2. That means f of 2, wherever there's x, you're now putting 2. It'll be 4 by 2, then minus 2, okay? Sorry for the way the pen is behaving. I'm not sure why. 4 by 2 is 8 minus 2. This is 6. So I now know when my x is 2, my y is 6. 1, 2, 3, 4, 5, and let's say 6 is here. So you're going to go all the way up, and you meet your 6 there. So now you're just going to join the points. So this is 6. You need one more point. You just joined 2 points, right? What is the other point? It is the limit. What was our limit? Our limit was what? As x was approaching 1, what was our limit? Our limit was from the right. We're coming from the right because we are getting the greater than. And our limit was 2. So that means it would be 1 would come where 2 is, but there'll be a hole there, right? There won't be a point, so there'll be a hole there. Now we can join the 2 points with a ruler and continue. That is your graph. So this is your graph of f of x is equal to 4x minus 2. But the reason why we left a hole is we are only getting greater than 1, so we can't take 1. Now let's go to the next one. You say 4 x less than or equal to 1. Okay, that means f of x, your f of x will be equal to 2 minus 4x. So we are going to take a value of x that is less than or equal to 1. We can start with the one with 1. We've seen that when x is 1, what is our limit? Our limit was -2. So when x is 1, it will be somewhere on -2, but we make it shaded. Why do we make it shaded? Because x is less than or equal to 1. That means we can take 1. So now we are going to say, we choose another value. We need 2 points, remember, to join. We can say let x be equal to any value that is smaller than 1. You can say -1. You would now say f of -1 will be equal to 2 minus 4 by -1, which is equal to 2 minus 4 times -1. You can punch in the calculator, you get 4, a positive. So it'll be 2 plus 4, which is 6. So that means when x is -1, your y is 6. So it comes all the way up to where we were here. Okay? And you can join the 2 points together. So you draw the graphs one at a time. That's all you got to do. And you have to stay true. I missed the point. So let's see if I do this. Let's see if I go this way. I don't know why it's misbehaving. Let me try to do this. Maybe it's the way I've put it. I've put the laptop. Let's see if I do this now. It should cooperate. So then I can be able to plot. Something like that, okay? My graph is ugly, but I just wanted you to see how we do the graph. You're done, okay? The concept, you get it. Now let's do this one again. Limit of f of x is equal to square root of x minus 4. If x is greater than 4, and then blah, blah, blah. Determine whether the limit exists. So now you're smart. Now you know how to do it. So you're going to say, remember that we always get one thing at a time. So you could first write down f of x. I don't want you to panic. Is equal to root x minus 4. That is for x greater than 4, and it is equal to 8 minus 2x for x less than 4. So that means I'm going to say the limit as x approaches 4 from the right, this is equal to, I look at this one here, x greater than 4. What do I use? Of f of x, sorry, you don't forget to say it's the limit of f of x. And this will be equal to the limit as x approaches 4, okay, the limit as x approaches 4 from the right of what is your f of x is going to be of 8 minus 2x. That's the one you're going to use. What is this equal to? Now we can go ahead and do it, right? Because our f of x, you've said it will be 8 minus 2x because you are taking this here x. Oh, you take the one year x, sorry, oh my gosh. You take the 1 year x greater than 4, which is the first one, right? Because we are coming from the right. Remember, your 4 is here. We are coming from the right, so we are greater. We are coming from the right, so we are greater. So you're going to say it will be for the square root of x minus 4. And this is a rational function, which means we use direct substitution to get the limit. So it will be just be the square root of where there is x, we are putting 4. The square root of 4 minus 4, which is 4 minus 4 is just 0, which is the square root of 0, and the limit there is 0. Now let's see, can we get the limit of f of x as x approaches 4 from the left? Okay, as x approaches 4 from the left. This is equal to the limit as x approaches 4 from the left of, what is our f of x? We use x less than 4 because we are coming from the left, so we are coming, that is your x, it's less than 4, okay, and we're going towards 4. So it's going to be, what is your, we use 8 minus 2x. I mean, it will be the limit of 8 minus 2x. Like that. And then what do we get in this case? We use direct substitution because this right here, to get a limit of something like this, this is a polynomial, so there's nothing unique. It's just the first method. You can check on the 4 method. So we are just going to substitute 4, okay? Because the limit laws apply whether you're coming from the left or right. For one-sided limit, we still use the same thing that we were doing. So we just plug in 4. So it's going to be 8 minus 2 by 4, which is going to be 8 minus 8, and it is going to be 0, all right? So you can now say the limit as x approaches 4 from the right of f of x is equal to 0, which is equal to the limit as x approaches 4 from the left of f of x, okay? Because it is also 0. We saw that the limits are 0. So you can now say, therefore, the limit of f of x as x approaches 4 exists, okay? Or you can say it is equal to 0. So that means it exists, okay? Once you do it, it is equal to 0. That's now the two-sided limit because both of the one-sided were existing and they were equal to one another. And you'll be done. And you'll be done. So in the next video, I'm going to split the video into two in case you want to watch one part. So the next part, I'm just going to be doing absolute value equations. The limits of those is the same concept. Let's see how it is. Goodbye for now. As soon as I closed the video, I thought I forgot to graph just so that I show you. Let me graph. Let's go ahead and graph so that we can just be comfortable with this graphing work of such type of functions. How would I graph this one now? This piecewise function. I always use the point where the things are happening. And here we can see that things are happening at x equal to 4. So I know that 1, 2, 3. At x equal to 4, that's where my things are going to happen, right? So now, what do I care about? I'm going to start with x greater than 4, which means I'm coming from the right-hand side. Okay, so it's going to be the values that are bigger than 4, right? So I'm going to say for x greater than 4, for x greater than 4, I know that f of x is equal to, I know that my f of x is equal to the square root. I know that my f of x is equal to the square root of x minus 4. So now I can be able to find things just by doing that, right? I know that my limit is a point, okay? It's a point we use. I know that my limit as I was coming from the right, because x greater than 4 means you are coming from the right. You are coming from the right. Don't forget that. So that means I'm going to say if I'm coming from the right, what was my answer? It was 0. So it was going towards 0. Remember that limit is the value of y. Limit is the value of y. So as I am going towards 4, y is going towards 0. So it is this point here. But remember that I can't include it, okay? Because in here it was x greater than 4. There's no 4 there. So that's why I put a big open circle with nothing. Okay, so that's where I'm starting from. Now, what else do I go? I pick one more point, which is like greater than 4, right? I can pick even 5 for whatever point I pick, okay? I can pick 5 or whatever point it is that I'm going to pick, and I'm going to see what value can give me. Let me just pick 7, so I'm going to say let x be equal to 7. So I'm going to say f of 7 is equal to the square root of 7 minus 4, okay? And that is equal to the square root of 3. So you could put in a calculator, just see what it is. Square root of 3 is 1.73. So I could say this is 1, this is 2. So it's somewhere here, just above 1.5, right? 1.73. And that meets with what? That meets up with x equal to 7. So x7 meets up with that. Now I can get one more. Let's try x9. Or we could even try x5, you know what I mean? What is x5 going to be? Well, x5 is going to be, you can say, let x be equal to 5. You say to me, why are you doing that? We only needed 2 points, the limit and one more point. But here I'm going to do this because there is a square root. If you have a square root, that means your function is going to be a curve. So you need about 3 points or 4 points, and then you can get a good curve. So I'm going to get one more point. I said let x be equal to 5 because 5 is greater than 4. So I'm going to get f of 5. And what is that going to be? The square root of 5 minus 4, which is the square root of 1, which is just 1. Okay? So it's going to be 1. x5 is going to be 1 like that. Okay, so if I'm to plot the curve is going to come like this. Something like that. That's going to be the curve. It's a curve. Okay, because it's a root. But things that have just a power of 1, no square root, no nothing, just a power of 1 like this. It's a straight line, so we need one more point. So I'm going to say for x less than, okay, for x less than 4, I'm going to go for x less than 4. I'm going to say your f of x will be equal to, is it 8 minus 2x? Yes, it is 8 minus 2x. 8 minus 2x, right? So now I know that the limit was 0 again, so that means it's still here. And look, this one is only, x is only less than 4, so I can't make it shaded. It's still going to be an open circle, right? And then now what else am I going to go do? I'm going to now find one point. I'd say let x be equal to anything like 3 or 2, because 2 is less than 4, any number. So I'm going to say f of 2 would be equal to 8 minus, oh my gosh, it is equal to 8 minus 2 by 2. Wherever there's x, you're now putting 2, which is 8 minus 2 by 2 is 4. And 8 minus 4 is just 4. So I'm going to say when x is 2, I got my answer to be 4, my y. So when x is 2, my y was, this is 1, this is 2, this is 3, and 4. My y was 4, so it'll be somewhere there. So I'm going to just, it's a straight line because the highest power is x, so I can just join my points, continue up, and then it will see. I'll see where it keeps going. That's done. You are done with your graphs, and this will be the graph of this thing, okay? If you want to now put other values just for decoration, it's up to you. Minus 4, which are the values that you won't use, okay? You can put them after so that they don't disturb you as you're plotting. So minus 4, minus 3, minus 5. You're done. So this is going to be your y-axis, and then this is going to be your x-axis, and then this part is root of, okay, it's f of x is equal to root of x minus 4, and then this part is f of x is equal to 8 minus 2x. You are done. That's how you plot it. Good. Now we'll look at absolute value functions. Bye. See you in the next video.